Everybody. Today we're going to take a look at square root equations and their graphs we'll take a look at tomorrow. So today's going to be all about equations, what you do to one side, do to the other side, opposite operations, and of course the goal is to get the variable by itself, whether that variable is an x or a y or z, whatever the variable is, your goal is to get that all by itself. So we're going to go through several examples. Some of them you might be familiar with, like if you see a square root, you're going to square both sides. And we'll also take a look at what if your index is something different than the number 2. So let's go ahead and jump in. A radical equation is an equation that has a variable underneath the radical symbol. Now, the radical symbol you might more familiarly know it as the square root. So this symbol right here that I just drew in right there, but it's technically called a radical symbol. The number on the outside is understood to be 2 if you don't see anything there. Otherwise, it's a 3, it's a 4, it's a 5, and you'll actually see that number there. So that's your index on the outside. To solve a radical equation, isolate the radical on one side of the equation and then raise both sides of the equation to the same power as the index on the radical. So let me zoom in here and we'll go ahead and get started. So for A, we're going to solve the square root of x plus 3 equals 5. We need to subtract 3 from both sides. So I subtracted 3 from both sides because we know that's the opposite of adding, to subtract. The opposite of multiplying is to divide, and vice versa. And then to undo a square root, the opposite of square rooting something is to square both sides. So I squared both sides. This little tiny 2 here, I squared both sides. Now this 2 and my square root are going to cancel each other out. So we're left with x. And 2 times 2 is 4. Now, we do want to get in the habit of checking our work. So whatever numerical answer you think that you found, you want to just take that extra 15, 30 seconds, take this number, substitute it back into our problem, and see if it makes a true statement. So, of course, you can use Desmos for this. For right now, I'll just do some mental math. If I take 4 and plug it in, the square root of 4 is 2, and 2 plus 3 is 5. So check this problem works. So you do want to get in the habit of checking your work to make sure your numerical answer works inside of your problem. B, you need to isolate the radical on one side first before you get rid of it. So let me box my radical. So we need to get that all by itself first before I try to undo it. So we need to subtract 2 from both sides. That's going to give us the square root of 3x minus 2 is equal to 4. Now the opposite of square rooting is to square both sides. So I'm going to put parentheses around both. And I'm going to square both sides. The square and the square root are going to cancel each other out. 3x minus 2 equals 4 times 4. Make sure you're doing 4 squared and not 4 times 2. So this is 4 squared. So we can type that in Desmos or any kind of calculator. From here, it's a straightforward equation. I'm going to add 2 to both sides. That gives me 18. And 18 divided by 3 is 6. So I added 2 to both sides. 18 divided by 3 is 6. So we are solving the equation. Okay. C. Again, you don't have to do the little box thing that I'm doing. I'm just trying to show you that you need to get the radical on one side of the equal sign before you try to undo it. So you cannot start this problem by squaring it. We need to start this problem by adding 6 to both sides. So that's going to give me the square root of 5x plus 1. Is equal to 6. And the opposite of square rooting is to square both sides. So 5x plus 1 equals 36. From here, I'm going to go ahead and solve the equation. Of course, feel free to pause it if you need some time to try by yourself. But I'm going to subtract 1 and divide by 5, and that'll give me my final answer. So subtract 1 and divide by 5. So my final answer is 7. Again, we'll make sure we're checking our work. You can type this into Desmos. So if you're going to check your work, you take the number 7, substitute it in here, and you do the square root of 5 times 7 plus 1, subtract 6 from all that, and it should give you 0. It works out, but that's a good idea for you to go ahead and get in the habit of checking your work. Now let's mix it up a little bit. So down here at the bottom, So those were all square roots. And the little number on the outside, your index, all of my indexes here were 2, 2, and 2. This index is 3 and this index is 4. I still can solve it, but we're not going to be squaring it. We're going to be cubing it or raising it to the 4th power. So for D, we need to subtract 1 from both sides. So we have the cube root of x plus 4 is equal to 2. So I subtracted 1 from both sides. Now that I have the radical isolated, on one side by itself, then we're going to get rid of cube rooting it. So this is the cube root of x plus 4. So we're going to raise each side to the 3rd power. So the opposite of a cube root is to cube both sides, raise it to the 3rd power. So this gives me x plus 4 is equal to 2 to the 3rd, which is 8. Again, that is not 2 times 3. That is 2 times 2 times 2. It's 2 to the 3rd power. Subtract 4 from both sides, and voila, x is equal to 4. E, so I'm going to go back to put my box around it. We need to get the radical on one side of the equal sign first before you undo it. So we need to subtract 2 and then divide by 3. So subtract 2, divide by 3. So I'm going to bring this down. Haven't changed anything about it. Just bring it on down. 8 minus 2 is going to give me 6. This is 3 times all of this. So this is 3 times the 4th root of 2x minus 4. So we need to divide both sides by 3. So this is going to give me the 4th root of 2x minus 4. And 6 divided by 3 is 2. Now this is a 4th root. This is a 4th root. We need to raise each side to the 4th power. So we're going to raise it to the 4th power here and raise it to the 4th side here. So the index 4 and raising it to the 4th power are going to cancel each other out. That's going to give me 2x minus 4. 2 to the 4th power is 16. Again, not doing 2 times 4. That's incorrect. That's 2 to the 4th power. 2 times 2 times 2 times 2. We're going to add 4 to both sides. And 20 divided by 2, I got x equals 10. So add 4 to both sides. If you need to literally be writing those steps out, nothing wrong with that. Add 4, that gives me 20. And this is multiplying, divide by 2, divide by 2. All right, F. 1/2 times the square root of x minus 5 plus 7 is equal to 8. Again, we got to get this radical on one side by itself first. So I'm going to subtract 7 from both sides. That gives me 1. I can think of this one of two ways. I can think of this as dividing by 2, in which case I would multiply both sides by 2, or I can think of it as multiplying by 1/2, in which case I would divide by 1/2. Either train of thought is going to give me the same answer. So I'm going to think of it as dividing by 2. So I'm going to multiply both sides by 2. So 2 and 1/2 are reciprocals of each other. They're going to cancel each other out. So I'm left with the square root of x minus 5 is equal to 2. Square both sides because that's the opposite of square rooting. So we're going to square both sides. Squaring and square rooting cancel each other out. So thus x minus 5 equals 2 times 2. And add 5 to both sides, got 9. So that's that. So that's the top half. So taking a look at those. On the bottom half and some more that we're going to do, we're going to take a look at what to do if you have a radical on both sides of your equal sign. And then we'll try a little harder ones, okay? So we got these 6 up here that we did. Pretty straightforward, very familiar, very similar rather to solving a regular equation. What you do to one side, do to the other side, etc., etc. So let's mix it up a little bit. Right here in the center of my notes here, if both sides of the equation contain a radical, raise both sides of the equation to the same power as the index on the radical to remove the radicals. So all that means is that if you have a square root on both sides of the equation, then we're going to get rid of that by squaring both sides. And put that word in there. All right, so let's go through these three right here. So all three of these have a square root on both sides. Square root on both sides, square root on both sides. So to undo a square root, we're going to square both sides. Square this side, square this side. Squaring and square root cancel each other out. So I'm left with 3x minus 2 equals x plus 6. I solve this equation, subtract x, that gives me 2x. Add 2, add 2. The opposite of multiplying by 2 is to divide, and 8 divided by 2 is 4. B, I see square roots on both sides. I'm going to square it, square it. Squaring and square rooting cancel each other out. We're left with 3x plus 4 equals 5x minus 6. We're going to solve this equation. Subtract 3x, subtract 3x. Add 6, add 6. Divide by 2, you get 5. And then we have one more. I have this square root right here on both sides of my equal sign. Square both sides to get rid of it. So we're left with 5x minus 9 is equal to 12 plus 2x. We're going to go through and solve our equation, do our opposite operations like we know how to do. Subtract 2x, subtract 2x, that's 3x. Add 9, add 9. And opposite of multiplying is to divide. So you might think that these are a little easier than the first 6 problems that we did. So these example 2 problems, if you have a square root on both sides, cancel it by squaring it. After you square it, it turns into a regular linear equation that you know how to solve. So keep the equal sign in the middle, where you do to one side, do to the other side, etc., etc., etc. Excuse me. So hopefully you find these a little more straightforward. All right, I got one more type of problem I want to take a look at. These down here at the bottom. A little more involved. We might have to multiply some stuff out, do box method. We might have to do some factoring, but we still can get our answer and we still can solve the problem. So we're going to solve, and then, of course, we want to make sure we check our answer. So let me just do one time, zoom in here. Okay, so let's try A. The square root of x minus 3 plus 5. Let's subtract 5 from both sides so that I can get the radical on one side by itself. So we're going to subtract 5 on both sides. These are not like terms. One is a variable, one is a number. I cannot put these together. They are not like terms. I leave it as x minus 5. The opposite of square rooting something is to square both sides. So I'm going to square this side, and I'm going to square this side. When you square this side, it is not x squared plus 25. That is incorrect. When you square this side, you have to multiply it out using box method or distributive property. So we're really doing x minus 5 times x minus 5. So somewhere off to the side, you should be doing the box method or distributive property to multiply this out. When you multiply that out using box method or distributive property, it gives you x squared minus 10x plus 25. From here, I need to take the x and the negative 3. I need to move everything over to one side of my equal sign, and I need to factor it. So I'm going to subtract x and add 3 from both sides of my equation and put them with the like terms over here. Subtract x gives me negative 11x. Add 3 gives me positive 28. From here, I go through and we're going to factor this. So this is a quadratic equation. I see that 2 up there. I am going to factor this. So we did factoring a couple weeks ago. You have that foldable or a chart or something to hopefully help you with your factoring. We need to think of 2 numbers that multiply to give me 28, add to give me negative 11. Again, multiplies to give me 28, adds to give me negative 11. Those numbers are negative 7 and negative 4. You set each factor equal to 0. So x minus 7 equals 0 and x minus 4 equals 0. X equals 7 here, x equals 4 here. Check your work, check your work, check your work. You would take 7, substitute it in here, work it out, and see if it gives you 7 because that's what x is. Take 4. Substitute 4 in here and see if it gives you 4 back. Absolutely, you can use Desmos. The only one that works when you substitute it back in is the number 7. That's the only one that works. Okay, B, it's a very similar process. Opposite of square rooting, we're going to square both sides. After you undo that, that's going to give you x plus 3. Again, this, when you see this here, that means to multiply it by itself. So 3x minus 1 times 3x minus 1. You can do box method or distributive property. When you multiply that out, you should get 9x squared minus 6x plus 1. So box or distributive property, if you need to flip back in your notes from when we did that, there's nothing wrong with that. From here, I'm going to move everything over to one side of my equal sign, and I'm going to factor it. So I'm going to subtract x and subtract 3 and move that with my like terms over here. So that's going to give me 0 equals 9x squared. Subtract x gives me negative 7x. Subtract 3 gives me negative 2. From here, I'm going to factor this. This is the 4-step method from a couple of weeks ago. Multiply the first and last number. Factor like normal. Divide by the first number, and then get rid of fractions. So you're going to have to go through the 4-step method for this problem here. So let me put a little note here, 4-step method. When you do the 4-step method, your factors should be 9x plus 2 and x minus 1. So when you go through and do the 4-step method for this problem, these are the 2 factors that you should get. You said, and these are squiggles, like don't think they're like anything. They could be, I'm changed to a star or something. So it's just a little note to let you know, hey, I'm going to do the 4-step method up here. Set each factor equal to 0. 9x plus 2 equals 0. X minus 1 equals 0. Solve each equation. So I get x equals negative 2/9 here, and x equals 1 here. Check your work, check your work, check your work. The only one that works is this number right here. And before I end this video, I will show you what I mean as far as checking your work. So let me pull up a Desmos tab here. Let me see if I can still put this in our viewing window here. Desmos. Okay, so I have done A for us already. So over here, it tells me to do the square root of x minus 3 plus 5 equals x. X is the number 7 or x is 4. So for the first part, I plugged in 7 where my pointer is highlighting there, moving there. So I plugged in 7. 7 minus 3 plus 5 should give me 7 back. And look, it gives me 7 back, so that means it works. When I plug in the number 4 into the left-hand side, notice the number 4 does not work, which is why over here on the left-hand side of your screen, I circled only the number 7 because 4 does not work. So make sure you get in the habit of checking your work.